Good morning, everybody. Yes, now we'll go to a new situation. We'll speak about the Réseau Lac Sentinel. I work at the Observatory of Natural Lakes in Haute-Savoie, in particular high-altitude lakes, and I work with Carole Birk about coordinating this network for high-altitude lake. It is a network aiming at following up the situation of high-altitude lakes in France for the moment, but that should extend to other countries. In this context, what do we mean by high-altitude lakes? More than 1,800 meters high. Because of their location, they are covered with ice, at least 6 months a year, sometimes up to 10 months. These ecosystems are per se oligotrophic, that is a low biological productivity. So we are in a different context, different from what we've heard today. And because of their location, they are difficult to access and considered to be kept away from human activities. But this is theoretical, because if we have a closer look, then we can see that they're not that far from human activities. These lakes are also by nature far from human activities, but nevertheless they can react to climate change. High-altitude lakes, if we have a closer look, show that they are subject to global pressure and local pressure according to the use that is made of them. Grazing, for instance, shelters. Some of them are used for hydroelectrical production and also tourism, angling. Small-scale systems. Afterwards, I'll speak about the Observatory of High-Altitude Lakes. Many of them are less than 10 hectares and depth maximum 30 meters, quite small systems. So very sensitive to physical, chemical and biological changes. And as other shallow lakes, there are natural archives of natural conditions of the past recorded in the sediments. They record the use of catchment areas, and as I said it before, physically, chemically and biologically. The network was born after a conclusion of different managing entities. One of them, we manage 5 lakes in Haute-Savoie. First conclusion, that in many of these lakes there was a rise in the production of algae and the appearance of cyanobacteria, a reduction of water quality in some lakes, and phenomena of hypoxia at the bottom of some lakes, with the disappearance of some species. I speak in a general way. We'll get into details afterwards. The purpose here, because these lakes are iconic, so we wanted to keep a natural situation of the lake. What do we mean by natural situation? We could start a debate, but in a nutshell, it's keeping the natural situation of the lake and keep human activities. In this network, we try to tackle several issues. We try and explain how these lakes function, how they evolve, What are the human activities impacts on these ecosystems? The climate change and these changes, and how can we forecast these changes and react in order to stop some dysfunctioning. So it is a very ambitious set of objectives. That's why we wanted to work with research laboratories in order to have a scientific approach and set up the right protocol. Here you can see the history of this network, and until 2009 some lakes were monitored in the Alps, not always at the same level. The same year, ONEMA set up an aqua program about the water resources in the Alps, and they discovered the need to have a more homogeneous approach in monitoring the lakes. In 2010, first meetings on high altitude lakes. They set up the basis of our network. In 2012, we officially started managing and coordinating this network, and in 2013, the Sentinel network organized itself as a official scientific interest entity. So it's a constitutional convention in order to allow managers and scientific work together in managing the lakes, and this way we could federate human and financial and technical resources. Stakeholders of the network. So we've got a group of managers. Among them, we and natural parks. Managers know the ground, and it's a real motor in order to impulse the following up, the monitoring on the longer term. Then we've got scientists in different disciplines in order to guarantee the correct quality of data collected and their analysis. They make more understandable the functioning of this system, and the users, they have a historical knowledge of these areas, and they ask questions.
So the objectives of the network is to increase the knowledge of how these mountain lakes work. We want to monitor the evolutions of these lakes, and to have better long-term management of these habitats. I'm going to tell you about 3 actions. We are going to talk about the Observatory of Mountain Lakes. We have a website. It has been online for a year with the maps that can help you to understand better which lakes are followed by this observatory. We have 22 lakes that are part of this observatory, mostly in the French Alps. We have lakes that are monitored by the managers thanks to the help of scientists. The biggest part of the job for this observatory was to set up a common protocol, standardized protocol between all the managers. There were talks that started in 2011 about that, and today we have a scheme that is that follows norm standards since 2013-2014, and so since 2014 we have been collecting the same kind of data as in all the lakes. That's the protocol. I'm not going to show it to you here, but we have a video that was created in 2016 that explains what the protocol is about. It's a 3-minute long video that explains to the users how the lakes are being monitored. There are different indicators that are looked into. In September, we So all the managers go to the lakes in September. Why September? It's because it's the end of the certification period on the lakes, even if we realize that some lakes have already gone through that period. And we follow transparency. We have vertical profiles that are done thanks to a parameter sensor. We have plankton sampling. We have chemical analysis of the phytoplankton and chlorophyll A, and we also follow up the temperature with oxygen levels. So we have high frequency data that are monitored in the lakes. All these are done at the deepest level of the lake. This was just to show you the different indicators that we follow on the 5 lakes in Haute-Savoie. There are some compulsory parameters, so all the managers have to go through this analysis. And then there are optional parameters that are implemented on some lakes, so chemistry, phytoplankton and zooplankton. In 2016, we've worked on chlorophyll A, and then we have specific studies. It's the case in Anterne, for instance, where we have studied macrophytes this year. Macrophytes, and we are going to continue that this year to complete the research. That was just to show you a little bit how it works at the observatory level. So we have campaigns that take place in September. Then all the data that we have are stored in a common database. It was huge work, but the idea was not to create a database from scratch, but to use what already existed. We use the Sentinel in the European Observatory for lakes, large lakes in Europe, have a database. So we used the same database. We worked with them to see how we could use their database to store our data. And so we've done that since last year. And all the follow-up on the mountain lakes are on the INRA website by all the managers. And this year they're all autonomous to do it, because until now we were in charge of uploading the data on the database, and today they can do it themselves. The managers can do it themselves. So it's metadata that is posted on the website for the general public. The data we have for now, it's quite recent, but a big part of the job was done in 2016. Could have showed you a few graphs, but you can go and check out the website, and you will see how the data is turned into a graph. We will do that every year, and in 2017, for the first time, we have analysis that are carried out to compare lakes from one another. The second tool that we have in the network are workshops. So scientists are going to follow specific sites on which they will carry out deeper studies, deeper research, and they are going to implement specific protocols. Just to show you an example, I'm not going to have time to go into details, but we have the Anterne Lake site. It is one of the lakes that has been followed for a while, about 20 years now, and we add a large number of data that has been collected in PhDs. But recently we have looked into this data to try and highlight some trends, evolutions. There was a study that was carried out by the EDITEM laboratory in Chambéry to look at the sediments and its impact on the lake. So it's what you can see here. You can look at the monitoring or measuring system that was implemented in the Anterne Lake. So you can see it's a lot more developed. We have pictures that are taken to look at the snow. We have meteorological stations as well to look at the impact of floods. Another site in the Maison Lake. Here we have different laboratories working on this lake. and we have high frequency data that are generated on this website, especially in terms of temperature and oxygen. So we have sensors every 2 meters. And so in our observatory, we have this kind of sensors as well, but only one at the bottom and one at the surface of the lake. Here it's every 2 meters, so it's a lot more intense. At the Musée Lake, there was a problem related to greening of the lake. To keep it short, the studies that were carried out, so we suspected rejection outputs of a house from the watershed, and the house was upgraded, new norms were applied, and now we can see that the greening still took place, so it's probably related to nitrogen on the lake. And finally, the last tool, it's an important one, it's the networking and communication about the results. So every year since 2010 we have organized yearly meetings of the network. We get together for 2 or 3 days to look at the situation, look at the ongoing studies, to improve the protocol, look at what is relevant, what is not relevant, to add value to the results, and to always create synergies with research and scientists to see what kind of research will be necessary in the future. There will be something that will be carried out in the coming years on paleo studies. So we're going to sample the sediments on the different lakes to look at the different layers of sediments to see if there were changes in the past, to look at the history of the lakes. So you have pictures of different events like that we organized. We have an interactive website. Until now we had different places where we could look at the data, but today we centralized everything on this single website. It's public data, you can go on it, and all the research work and the PhD work are posted on the website. So if you want to look into a lake, then you can go on the website and you will find all the information. To conclude, on this long-term follow-up, well, I didn't tell you about very technical things like we heard today, this morning or this afternoon, but it's because we are only starting at looking at data and analyzing this data. But today the point is to have a standardized scheme with a standardized protocol, common tool of storing data, communicating together, networking. For us, it's a big step forward. We have very operational tools. One of the challenges for the long-term follow-up are funding. So all the partners pay for their own studies, but we also receive other kinds of fundings, like from the water agency in France. So it's a project until the end of the year, and we are trying to think of new ways of funding for the future. Biggest challenge is to find money for the decades to come. It's not an easy task. And so we have a strong momentum. We need to work even more closely with scientists, and this pressure from the funding bodies to get results. It's sometimes difficult to find the results, but it's good for us to have this forward way of thinking about how to add value to the results of the research. And there is something else. We want to move beyond our French Alps. We are in contact with the Pyrenean. There is someone who could tell you about it. Even if the Pyrenean lakes are not in our network, they have the same kind of protocols on their lakes, so we'll be able to compare their data with our data in the Alps. And we also have discussions to open our borders to Switzerland and Italian lakes. Thank you very much for listening. I had a question about the size of the lakes. Are they below the lakes? below the site? Yes, they are below, and they are in specific contexts. It is the challenge for us when we qualify the state of the lakes. If we look at the Water Framework Directive, the systems are so specific that we don't know how to position ourselves. Yes, we use protocols that are inspired by the Water Framework Directive, but we cannot really compare the data we collect from the data collected in other lakes, in other places. I would like to know, out of your 22 lakes, were you able to identify murolitic lakes? So lakes where the bottoms of the lake have no mixing? Yes, there are some. We have anoxia in the Brévent lake, which is really impacted by that phenomenon, and also in the Écrin area. And yes, we have blue algae appearing in some lakes, not in all of them, but yes, in some of them. So lakes that are in lower altitude. So we are between 1,800 meters and 2,800 meters. And the ones that are at the lowest altitude, so lowland lakes, let's say, we have changes that are stronger than the ones that are higher. In France, you have the Pavin Lake in Auvergne. Sorry, I can't hear if he's not speaking in the microphone. So the temperature is been measured regularly since 2016. These campaigns, this measuring campaign, only take place once a year in September, but we would like to increase the frequency of our monitoring. But for now, yes, it's once a year. And there is a limit to it, absolutely. The idea is that we have to focus also on the cost-benefits ratio. The managers don't really have more means, and it can be too demanding for them. Other questions? We have time because there is a break right after. Yeah, there is a question. I have a key question. What are the biggest challenges to set up such a network? So the main challenge is money. Because we are coordinators, for us it is complicated. It's becoming more and more tense because the money we get is for 1 year, 2 years, maybe 3 years, but not for longer than that. And looking at European funding give us more stability on the long run. But yes, European fundings are complicated to deal with because they ask us for receipt for everything. So you know what it is. But what is also complicated is to find a way to make everyone happy. So all the partners have their own vision. And when we go and talk with scientists, they all have their own specialty. And they all try to get a bigger piece of the cake, basically. And it's not always easy to find a way to make sure that everyone is happy. For the scientists on the specific sites, they have fun and they keep busy, but they know that for us, we have management questions, and sometimes it's difficult to turn our management questions into scientific questions. Sometimes there is a difference between us and scientists, but it's good to get around the table and talk about it. But the fact that we are different type of stakeholders makes it complicated. It also makes it richer. Are there any other questions? No, yeah. Just a comment about what you said before about the atmosphere input. Is it something that you thought about using on the lakes? Yes, there are already studies that were carried out about PCB and nitrogen. So there were some studies that were already carried out. It is not something that we are looking into for now, except we look into it when we start studying at the sediment layers. But on the Musel Lake, we have a lot of data about that. On PCB particularly. And this data enable us to look at these elements. So, but it's not something that we are going to work on right now.